Okay, just going to go over some of the practice test problems. Realize one, the order is randomized and the numbers are randomized. So these may not be, like this first one I'm working may not be your question number one, but these are the type of problems that you should be able to work. So the first thing I'm going to look at is how could I change 8/1/6, this mixed number. Okay, so hopefully you're getting these definitions down. A mixed number has a whole number, and a fraction. All right, so remember how you do that is you multiply 6, the denominator, times 8, and then you add the numerator, and you always keep the same denominator. So 6 times 8, 48 plus 1, 49/6. And you can always, in fact, let me put that here, denominator stays the same. You can always check this. So let's say check, which kind of goes into another type problem. How could you check this? Well, you could say 6 divided by 49. I know that goes 8 times. 8 times 6 is 48. I have a remainder of 1. And how do you write this out? 8, my remainder, over what I'm dividing by. And so I can see that that works. So that's kind of nice to be able that you can check these. All right, so let's see what else. So let's say I have something kind of the same type problem, but you know, how do we deal with if we have decimals? So remember, the number on the bottom goes outside, and then you're going to divide by 29. Well, the problem is that goes 0 times. So what you need to do is add some zeros here. Now, how many zeros do you add? Well, I don't know until I don't have a remainder anymore. So I know 4 goes into 29 7 times. So 40 would go into 290 7 times, and that would end up being 280. Right? And so then I bring down the next value. So I get 100. 40 would go into 100 2 times, because 40 times 2 would be 80. That would be 20. I bring this one down, and now I can see 40 goes into 200 5 times, and that's 200. So I get a 0 remainder. So I know that I can stop, and this would be my final answer. All right, I'm going to just do these in parts. As you'll see, this is called part 1, so I don't overwhelm you with 50 problems in this part. Students typically will have issues with negative signs. In fact, there's some funny memes out there that'll say, you know, people will argue about this answer, you know, to something like this. And you kind of just go by the rules. So the rule means that when you have a negative and a negative, that makes a positive. And then please excuse my dear Aunt Sally, parentheses, exponents, multiplication and division go together, addition and subtraction. Well, all this has is addition and subtraction, so you just go from left to right. When the signs are the same, you add and you keep the sign. And so I can bring the plus 19 down, and from here I can see that I get 8. All right, if we have something like a decimal, and I want to turn this into a fraction. This is remembering your decimal placement. So this placement right here is the tenths. The next placement would be in the hundredths, and so on. This is in the hundredths, so I can rewrite this as 79/100. 100, and just kind of need to make sure and check that can you reduce it, and I don't see any way to reduce it. All right, what if you're asked to divide 15 divided by 5 1/4? Well, this is a little hard to do. I mean, what this is actually saying is this: 15 over 5 1/4. So the first thing you want to do is get rid of that, because it's going to just confuse me, is I want to convert this value. Okay, so I still have my 15 divided by, I'm going to convert this into the improper fraction, which is 4 times 5 is 20. 20 plus 1 is 21 over 4. And you can write 15 as 15 over 1, right? Well, what's the rule with when you divide fractions? You multiply and flip the second fraction. Okay, so you multiply and flip that second fraction. Now, of course, you can pick up a calculator and put this in a calculator, but what I try to do is break these down. I know 3 times 5 is 15, and 2 times 2 is 4. And the only reason why I'm doing this, I'm going to see if something will cancel. 21 is 3 times 7. Aha! So I can see that would cancel. So all this is doing is it's making it where I have something a little easier to multiply. 5 times 2 is 10. 10 times 2 is 20. And thus I get 20 over 7. All right, what else do I have going on here? I'm just kind of looking through your practice test to see the kind of things that I haven't worked with the fractions, because I'd like to kind of keep these together. Maybe I'll do a reducing one next, because that's kind of in this same area. So let's say that you are given the fraction 135 over 216. Now, I kind of have a rule of thumb. If both of these numbers are even, and they're not, but if they're both even, I just start dividing out, a 2. If they both end in 0 or 5, I start dividing out a 5. Well, sadly, that doesn't work for either one of these, right? Because, I mean, I say for either one of them, it does work for one but not the other. And so if it doesn't work for both, then I go straight to prime factorization. But now I can use these little hints over here, and I can start dividing. Oh, there's another cool one too. So if the numbers add as a multiple of 3, you can divide by 3. You know what that means? What's 1 plus 3 is 4. 4 plus 5 is 9. So I know, I'm going to do my 135 here. I'll do my 216 over here. I know that I can divide by 3. I mean, that's kind of a cool little trick, right? If those numbers, you add them, 1 plus 3 is 4. 4 plus 5 is 9. 9 is a multiple of 3, so you can divide this by 3. Well, 3 goes into 13 4 times. I'm going to kind of do that over here on the side. 3 into 135 would go 4 times. That would be 12. And so I would get 45. Now I kind of look at what I wrote over here. 1 ends in a 5, so I think I could factor out a 5. And I remember 5 times 9 is 45. And then finally, 3 times 3 is 9. And so I can do the same thing with 216. Let's see if that trick works. 2 plus 1 is 3. Plus 6 is 9. Well, what do you know? So both of these I can see have in common that 3. And then I think of 72. I think of 8 times 9. It's just what comes to me when I think about this. And then that would be 2 times 4. The 9. 3 times 3. And then the 4. 2 times 2. So this is prime factorization. So what I want to do here is I want to see what are things that they have in common. The prime factorization. Well, it looks like a 3, so that's in common. It looks like another 3 and another 3. Now remember, I'm only looking at these last values. Okay, so it looks like in this case, all I have left is the 5. Everything else is kind of canceling out, and it looks like I have these values left. So you know what the final answer is? I know, please tell me, Cindy. This was my numerator, 5. My denominator is that 2 times 2 times 2, which is 5/8. Now, you know, you might be like, well, that is way too complicated. I have seen students do it this way, 135/216. And the first thing they do is the 3 times 45, right? And then the 3 times 72. And now you can see that cancels. And then next I have what, 9 times 5 and 9 times 8. Look at that, baby. And so I get the same answer. Some students like this way better, but it is good because you're going to need it later to know how to do prime factorization. All right, this is about 11 minutes, so I'm going to stop this one and I will stay tuned for the next video.